Good morning, student. In this lecture, we are going to discuss about the design of logic circuit using programmable array logic. Now, first you see that one programmable array logic, what it is, right? So this is a programmable array logic. Programmable array logic. Suppose they may ask as PAL, programmable array logic. The last class we discussed about PLA. PLA is programmable logic array. So here we are having programmable array logic. Here we can program in the input side, right? So here we are having now that input we are having four digit input, right? A, B, C, D, four variable input, right? So I1, I2, I3, I4 or A, B, C, D, right? So that one is each one as we are having now inverting and non-inverting. So buffer and inverter is going to have that one input, right? So input is here we are having now this one as A dash A, B dash B, C dash C, D dash D. And also here we are having now the AND gate, wired AND gate. So you can connect with that if whatever that input want, right? So 10 lines are connected, can be connected and it will connect with AND gate. And the output is going to connect with OR gate. And also we are having a feedback path as this F1 is having now the feedback with that one, right? So here we are having now F1 and similarly that in the, here we are having this actually feedback path we can have now, right? So here whether if we are having, then we can give now one feedback path or two lines can be connected with wherever you want. Suppose here you see this one in that example we are having now w x y z function, four functions are there. Then in that function here first function is 2 12 13. The last function is here we are having 2 12 13s are there and the remaining 1 and 8. So here 2 12 13 we are getting that output of that w and then we can connect with and add it, right? So here if you are using that Karnaugh map we can have a Boolean expression. So the w is abc dash and a dash p dash cd, right? So that is 2 12 13, right? How it is actually in the Karnaugh map. So here we are going 0 0 0 1 1 1 1 0. Here also 0 0 0 1 1 1 1 0. Right? Now here that input is here 2. So that here 2 is 0 1 2. 2 is 1 and 12 is 1. So 12 is here. 12 is 1 and then 13 is 1. Right? 12 and 13. So we are having only one pair. Only one pair and this one is alone. So we are having that function is here AB, AB, the function is ABC dash, ABC dash plus here this one as A dash B dash C D dash, A dash B dash C D dash. So this is the function. Now this function and also here we are having 1 and 8. 1 and 8 we are having now that line. So 1 and 8 is we are having now that 1 and 8 we have to add it with 2, 12, 13 and 1 and 8, right? So this is 1, this is 8. So we are having the separate, here we are having this one and this is 1. Then here we are having now this one as we can have a pair. This one as for this one we are write the function and this one as, so for this two we are having W and here we can have pair and this is a separate one. So for that pair we are having equation is that equation is A C dash D dash, A C dash D dash, A D dash C dash for this pair and the alone is here A dash B dash C dash T. So we will get that output of that first function and then added with this two. Then we will get now the last function, right? So what? Here we can have now the connection, right? So W. Now if you are having the W function, then here what we have connected is A, B, C dash. So this is we are having now. Suppose this is A. So A, B, and then C dash. C is here, C dash. C dash is this one. So A, B, C dash. A, B, C dash we are getting now as indicate. A, B, C dash. Then another one A dash, B dash, A dash, B dash, C, D dash. So A dash, this is the line. A dash, B dash, and then C is this one, right? And then C is this one, C is this one. So here we are having now C dash is this one. C is this one, C dash, and then we are having now C dash, then C, and this one is C, and then D dash. D dash is this one, right? You are getting now W here. Now this W is get back as a point. So here the last function for that one you can get it now. This last is here. So here we have to connect with this point. So in that one AND gate, so we are having the W. So W point itself. And then here A dash C dash you have to fill. So A, then C dash, and then T dash. So this is the case. Next one, A dash, A dash, B dash, then C dash, and then D. So here we are having W, then AC dash T dash. This is AC dash T dash, and then this one is we are having now A dash, B dash, C dash, E. So here this W is going to be reused in the function. So what? Then you have to give the feedback path and you have to connect with here for getting the W. Then this is as usual, then we have to fill that one, right? So these two equations are there. Then you have to fill these cases and we have to get it now. So here we are having now, this is A, B, C dash, right? So here A, B, C dash, and then we are having now these three functions. So we are having now 1, 2, 3, 4. So we are having here only 3 lines are there. Oh, sorry. Here this is a W, right? So only three is there. So you are having now these two. We will get now, and then we are going to have cases. So here in that way we can fill now, right? So programmable array logic, you think about that one. Input, then input is we are having inverting, non-inverting, and you have to connect with the 3 AND gates, then one OR gate, and then here this is AND gate OR gate, right? So if this path is required, if required, then we have to make it as. Right? So this one is we are having. So whenever we are having the repeated, then we have to give now the feedback path, then we will get now. So this is the ready-made programmable array logic. Then you have to use your functionality in that circuit, and we have to use the required points according to the equation. In that equation, we are having now the one output is going to have as one term. Then you have to use that one the feedback path. So this is a way of designing the logic gate using programmable array logic. So suppose they may ask this question as this function you have to implement in the programmable array logic, right? Then you have to find out the functionalities. Only 3 AND gates are there, so you have to here 4 terms. Then we reduce that one and 3 terms. Then you can have that design, and you have to draw the dots and you have to draw the diagram. That's all in the programmable array logic. Suppose they may ask question. So you have to answer properly. So we can stop here this one.